Hello, this is Ms. DB, and today we are going to continue with 12.3 Arithmetic Sequences and Series. This is part 2. So we're going to continue finding the indicated terms of an arithmetic sequence given two terms. We have one example of that left to do, and then also find the sums of arithmetic series. So because arithmetic sequences have a common difference, we can use any two terms to find that difference. So let's say that we are given the 8th term and the 14th term of a sequence, and we want to know what the 5th term is. So our first step is to find the common difference. So what we're going to do is we start by writing the general rule that we've been using all along, and we're going to let this one be a sub 1, the lower one, and this one be a sub n, and we're going to plug those into the formula. And there's a mistake here. Oh, and instead of n minus 1, we're going to put 8 here because I replaced a sub 1 with a sub 8 here. So I have to replace this with 8, which matches this 8. I'm going to use n as 14 because it's the 14th term that I'm using here. So n is going to be 14. Instead of 1, I'm changing that to 8 because I'm starting with the 8th term. And then, let's see, is there anything else I need to fill in? I think we got the rest. All right, so we have a sub 14 equals a sub 8. I'm going to plug those in next. I'm going to use the 14 for the n, and 1 becomes 8, and then common difference of d. And remember, that's what we're going to be trying to find. So now I put a sub 14 in. Oh, they simplified first. 14 minus 8 is 6. Now I'll put the a sub 14 in, which is 157, and a sub 8 is 85. So we subtract 157 minus 85 is 72, equals 6d, divide by 6, and you get 12 for d. So that was just to find d. And we'll look at another example so we can go through those steps again. All right, so now that we know what d is, we're going to use d equals 12 that we just found, and now we have to find a sub 1. So we write down the general rule again. When in doubt, write that general rule down, and we're going to put in what we know. Now we're looking for a sub 1 this time, but we know a sub 8 and we know a sub 14. You could use either of these. It's generally easier to use the smaller numbers, so we'll use a sub n. We'll use a sub 8 there. And we're looking for a sub 1. N will match our term that we're given, a sub 8. And we now know that d is 12, so that's where the 12 comes from. And so now a sub 8 is 85, which we got from here. And we simplify. 8 minus 1 is 7. Times 12 is 84. So we have 85 equals a sub 1 plus 84. So we subtract 84 from both sides, and we get 1. So a sub 1 is 1. All right, so now we know d equals 12. We know a sub 1 is 1. So now we're ready to find the 5th term. We have everything we need. Once again, we write down the general rule. And now it's like the simplest problems that you could get with arithmetic sequence, where you're just trying to find a specified term when you know all the other important information, like what is the common difference, what is the first term. So we plug that in, and we're looking for the 5th term. So we're going to replace n's with 5's here. And we will get 1 plus 5 minus 1 is 4, so 1 plus 4 times 12. Or 1 plus 48, and that of course is 49. So there's a lot of steps to do this, but you have all the information, and none of the math is hard. It's all just plugging it into the general rule and then working with what we got in order to find the pieces that we need. All right, so this is an example right from your worksheet, so that will help you on your worksheet here. So a sub 2 equals negative 133, and a sub 3 equals negative 121. We want to know what the 10th term of this is. So our first step is to find the common difference. So we write down the general rule, as always. Now we're going to let this one be a sub n and this one be a sub 1. And in here, since we're using a sub 1 as our second term, we have to replace this with 2. So a sub 3 equals a sub 2 plus 3 minus 2 times d. All right, now we are going to simplify that as much as we can. 3 minus 2 is 1. So that leaves us to a sub 3 equals a sub 2 plus 1d. And now we're going to put in our negative 121 for a sub 3 and our negative 133 for a sub 2. And we add 133 to both sides and we get d equals 12. Now, some of you may have noticed that these are consecutive terms of the sequence. You could have done this problem simpler by taking negative 121 minus the term right before it, because they happen to be right in a row. That only works if the two terms that they give you are right in a row like that. Then you can find the common difference quicker and you'll get 12 for that as well. All right, now that we know what the common difference is, we're going to find a sub 1. So we're going to, they told us that one of our terms was negative 133. We are looking, that was the second term, so we're going to use 2 for n and 12 for d. So negative 133 equals a sub 1 plus 2 minus 1 times 12. And then 2 minus 1 is 1 times 12, so that's just 12. So this really becomes negative 133 equals a sub 1 plus 12. So we subtract 12 from both sides to find that a sub 1 is equal to negative 145. And that's a sub 1. Now that we know a sub 1 and we know d, we're ready to find a sub 10. So now we have everything we need. We know that a sub 1 is negative 145. We just found that. In step 1, we found that 12 was d. So we plug in all the parts that we need. And we also know that n is 10 because we're looking for the 10th term. So a sub 10 is equal to negative 145 plus 10 minus 1 is 9 times 12. So we have a sub 10 equals, oh, they jumped to that pretty quick, negative 145 plus 9 times 12 is 108. So we have negative 145 plus 108, which is negative 37. So the 11th, oh, sorry, I edited this somewhat to match our worksheet. So the 10th term is negative 37. And there you go, number 3. Okay, in lesson 12.2, we wrote and evaluated series. An arithmetic series is the indicated sum of the terms of an arithmetic sequence. So when you're looking for a series, the difference between a series and a sequence is that there'll be plus signs. And we did this with the sigma notation. So we can derive a general formula for the sum of an arithmetic series by writing the series in forward and reverse order and adding the results. You won't have to do this, they're just showing how they got this formula. So they came up with this formula. This is what we will be using. That the sum of so many terms of an arithmetic series is going to be equal to the number of terms times a1 plus an, all divided by 2. And here's an example with the sum of the numbers 2 plus 4 plus 6 plus 8 plus 10. You need to know the ending point of your series, and then you add the beginning and the end, and divide it by 2, and then multiply by how many terms you have. And then you get the sum. So this is a lot easier than adding them all up individually, especially if you have a whole lot of terms. If you only have a few, you can just find out what they each are and add them up. But if you have a lot, then this formula will be a lot easier. All right, so here we have our first problem. It says we want to find the sum of the first 18 terms. That's what this means. S of 18 means they want us to add the first 18 terms, and then this is the series. 13 plus 2 plus negative 9, and so on. So that would be a lot of work because we don't even have them all written down, and we'd have to find them, and we might make mistakes, and there's too many. So here's what we're going to use the formula. We already know a sub 1, we already know n, but we don't know a sub n. So we could already put in that this is 13. We could already put in that we're looking for the 18th. But we need a sub n, and in order to find a sub n, we need the common difference. So the common difference is you take 1, the second term, minus the term right before it, and 2 minus 13 is negative 11. I like to check that and just do the third term minus the second term would be negative 9 minus 2. That's also negative 11. So we know D. Now we're going to use D to find the 18th term. So here's the formula for the 18th term. We use a sub 1 plus n minus 1 times D. So a sub 18 would be 13 is a sub 1. Now we know the difference is negative 11. And n, of course, is 18 because we're looking for the 18th term. So that's 17 times negative 11, and then we have to add 13 to that. So get your calculators out and double check your answer, and you should get negative 174 for the 18th term. So now we're ready to plug into this formula. We have everything we need. Now we know that a sub n is negative 174. We already had written what n and a sub 1 would be. Now it's just math. Now it's just simplifying. Don't mess up on your subtraction there. Take 13 plus negative 174, hit equals, divide it by 2, and then multiply the whole thing by 18. Don't forget to hit equals here because if you just type in 13 plus negative 174 divided by 2, your calculator will do this and then add 13 to it. You want to add this part first, then divide it by 2, the answer. And you should get negative 1,449. So pause the video right now and just type that into your calculator and make sure that you get the exact same answer. All right, so we say that this is the arithmetic sum, but really it's just a partial sum. We can't find the complete sum of an infinite arithmetic series because it's infinite. You're going to keep on adding, and you're not going to be able to find the sum of the whole thing. So we have to know what term we want to go to in order to find these sums. In this one, this is sigma notation. We want to go to the 15th. The top number tells you the term to find this to find the sum. That's going to be n. And your first term, you'll have to find it by plugging a 1 in here and simplifying. So let's find the first term. 5 plus 2 times 1, that's just 5 plus 2 is 7. Now let's find the 15th term. This is easy too. 5 plus 2 times 15. You just replace k with what you want to find, what term you want to find. So it's 35. So now we're ready to use this formula. We know a sub 1, 7. We know a sub 15 is 35. We just add those together. And then you divide that answer by 2, and then you multiply by the number of terms you have, which is 15. And we will get 15 times 21 equals 315. So it's a little bit easier when it's in sigma notation. You can also plug that into your calculator if you have a graphing calculator at TI-84 or TI-83, and you should get the same answer. Okay, here's number 7 from your worksheet. This is the one where it's a little bit trickier. So the first step is to find the common difference. So take 2.9 minus 3.2, and that's negative 0.3. Then double check 2.6 minus 2.9. Yeah, that's negative 0.3. All right, so we got the common difference. Next step is to find, we know that a sub 1 is 3.2, but we don't know the 18th term yet. That's why we needed the common difference. There's no common difference in the formula, but we need it to find a sub n when you're given a list of your series. So the 18th term, we plug in the general formula, a sub n equals a sub 1 plus n minus 1 times d. You're probably getting close to memorizing that. A sub n would be the a sub 18, a sub 1 is 3.2, and we keep solving this and add 3.2 to that, and we get that a sub 18 is negative 1.9. And now we're ready to use our sum formula. We're looking for the 18th term. So that will be n will be 18. A sub 1 is 3.2. A sub n is a sub 18, which we just found is negative 1.9. And we have to divide all of that by 2. So I got my calculator out, and I take 3.2 minus 1.9, and that is 1.3. So 1.3 divided by 2, and 1.3 divided by 2 is 0.65. And 18 times 0.65 is 11.7. So S of 18 is equal to 11.7. Here's another example from the worksheet. This is number 9, and in this problem it's written in sigma notation, which is kind of nice actually. We're going from k equals 1 to 20, so we're looking for the 20th term. And our explicit rule is 88 minus 3k. So our first step is to find the first and the 20th terms. So all we do is plug in, we use this, and we write a sub 1 equals 88 minus 3 times 1. We replace k with 1 for the first term. And 88 minus 3 is 85. That one's pretty basic. The second one, we take 88 minus 3 times 20 because we want the 20th term. And that's 60. So 88 minus 60 is 28. Now we're ready to plug those into the formula. We have a sub 1, that's 85. We're looking for the 20th term, or the sum of the first 20 terms. So a sub 20 is 28. And then we are going to continue plugging them in and solving. So, and n is 20. So we have 20 times 85 plus 28, all divided by 2. So 85 plus 28 is 113. And we have to take that divided by 2, which is 56.5. And then we have to multiply that by 20. So we end up with our sum as 1,130. And this was S of 20. So that's the sum of the first 20 terms is 1,130. On your worksheet, this is an optional section to do the application problem because the other ones do take quite a while, but it's not that hard. It's just using what we have learned for a real-world problem. So we have the center section of a concert hall has 15 seats in the first row and then 2 additional seats in each subsequent row. So it kind of goes like this. 15 seats, and then they'll have 17 seats, and so on. So we start by writing the first few terms. I do. 15, 17, 19, and so on. The common difference we can find pretty easily is 2, and we know that a sub 1 is 15. So we write the general rule, and we plug in what we know in order to find the 20th row. And then we simplify. A sub 20 equals 15 plus 19 times 2. 19 times 2 is 38. So we get 53 seats in the 20th row. Now what if they had asked us to find the sum of all the seats in the first 20 rows? So we would have to take what we know. We know that there are 53 seats in the 20th row and 15 seats in the first row, and we'll plug them into this formula. So we're looking for S of 20. So 15 plus 53, and then you divide that by 2. 15 plus 53 is 68. 68 divided by 2 is 34. and 34 times 20 is 680. So that is not bad at all. All right, so if you have any questions on these worksheets, please let me know. Otherwise, have a wonderful day.